Hello everybody and welcome back. We'll be doing our next 4 questions on the 2016 midterm in this video. So that'll be 13 through to 16. Okay, so those 4 are what we're going to tackle now. 13. So here's our function. It's a piecewise function. We've got f of x is cx squared minus 2 when x is less than 1. 3 minus cx when x is greater than or equal to 1. F of x is continuous at x equals 1 when c is equal to. Alright, so what do we need for continuity? Well, we need all the values, the value of the function at 1 to agree with both of the one-sided limits. Okay, so we're concerned with 1, so let's look at the limit from below. So these are values of x that are strictly less than 1. Okay. And then when this is a polynomial, so we can just plug in c times 1 squared is just c minus 2. How about the limit from the other side? So that'll be f of x, but these values are strictly greater than 1, so our function is going to look like this bottom function. And so again, it's a polynomial, so we can just plug in. So 3 minus c. And if we really quickly, I guess we can write up here, f at 1, well, 1 is greater than or equal to 1, so this is 3 minus c times 1, or 3 minus c. So these values all need to agree. 3 minus c here and 3 minus c here agree, but really this needs to be equal to c minus 2. Bring the c's over to the other side, so we'll get 5 is 2c. c is going to be 5 over 2, and that's going to be b. All right. 14 here. The graph of the function y equals g of x is pictured below. On what intervals is the function ln g of x continuous? Okay. Well, it's worth noting that ln g of x is a composition of 2 functions. So when g of x is continuous, we already know ln is continuous. So at any point g of x is continuous, ln should be continuous there as well. Okay, what else can we note and observe? Well, the problems are sort of happening in here, near 2, 5 over 2, 7 over 2, and 4. Okay. We also might think, well, what values can you plug into ln? So ln only allows certain values. So ln of x has domain 0 up to infinity. So down here where g of x becomes negative, I can't put those values in there. That's kind of interesting, and that also narrows some things down for us. So over here from 2 up to about 1, which actually they didn't include the 1 on their graph. Wonder if we fixed that year. It's been a while. Anyways, this should cross at 1. So for values of x going into g that are headed towards 1, function g is heading towards 0 from above. You can always plug in anything above 0 into ln. Okay? So anything below 0 would be negative values. You can't plug negative values into ln. So looking at things like b. Well, b is right out because things like 0, you can't plug g of 0 in there because that would be ln of g of 0 is ln of negative 1, and that doesn't make any sense. Similarly, c is out. Now, d is good, e is good. I'm not including a because you'll notice between 1 and 2, we've got good values. Okay? Now, you can plug in things like 1 into ln. You can plug in anything above. So really, we've narrowed ourselves down to D or E. Now, if I had to just guess, and we don't want to be guessing in question 14 unless we've done all our work and come back to it at the very end, I would guess the answer is probably E, just because of, look at all this craziness in here. Okay. D says just anything beyond 1 will count. I'm inclined to believe that the craziness will cause us some problems. Alright, so let's clear a bit more space. Alright, between D and E. Alright, now E is quite specifically avoiding 5 over 2. D is not. So let's think about this. Could we have 5 over 2? Well, 5 over 2 is a point where G makes a bit of a jump. Okay? So we could say like the limit as x approaches 5 over 2 from below of ln g of x. Does this make sense? Well, if we're approaching 5 over 2 from below in our g function, remember ln is continuous, and limits are allowed to sort of switch around with continuous functions. We're really asking, all right, what does it look like g is doing as we approach 5 over 2 from below? And it looks like it's heading down to about a half. So we're looking at ln of a half. But if we were to approach 5 over 2 from above, remember, limits can come inside continuous functions. What's g of x doing as x approaches 5 over 2 from below? Well, it's going all the way up to about 1.5. Well, these two values are not the same. So if the one-sided limits don't even agree, you definitely can't be continuous at 5 over 2. That rules out d, so e must be our answer. Okay? A lot of thinking going into that question, but we just needed to read and interpret the graph properly and know things about our good friend ln. Okay, 15. Find the limit as x approaches infinity of this big behemoth here. Well, I notice I've got an x to the 5 on top and on bottom. So what I'm going to do is multiply by 1 over x to the 5. So I'll get 12 minus 1 over x cubed plus 1 over x to the 5 on top. On bottom we'll get 4 plus 5 over x plus 7 over x squared minus 1 over x cubed minus 1 over x to the 5. But of course all of these go to 0. They're some of the limits that I told you to memorize. Limits as x goes to infinity, or if they're defined negative infinity, all of these go to 0, and we're just left with 12 over 4, better known as 3. And there we go. Alright, the last question for this video, 16. Alright, so this is a popular question. It's one, I believe, lifted directly from the textbook in, I want to say, 2.6. Okay, so what have we got? We've got quite a bit of an expression here, root x squared plus ax minus root x squared plus bx. We don't even really know what the a and the b are. They're just going to come along for the ride. Okay? Now, just like in the last question, we multiplied by a sneaky one. We're going to do the same thing here. What we're going to try and do is use a difference of squares. So multiply, same thing, top and bottom. Okay. But then, when we multiply this through on top, and if you want to, FOIL it all out, but hopefully you remember difference of squares from high school. You'll get x squared plus ax minus x squared plus bx. And this will all be over on the bottom there, x squared plus ax plus root x squared plus bx. Now the nice thing here is these x squareds go away. And we've got a minus b. I'm going to actually factor out an a minus b from the top. Pull it out. And so we'll just have a single x over root x squared plus ax plus root x squared plus bx. Now, what's the largest degree on top? X. What's the largest degree on the bottom? Effectively, the x squared and the square root cancel each other out. So we multiply by 1 over root x. So we still have this a minus b, which makes me think the answer is either E or C, just looking at them. Okay. Now the x is tending to infinity, so we don't really have to worry too much about any of this. So we'll just quickly bring all these in. It'll be 1 plus b over x. As x tends to infinity, these two go away to 0. And so really we have a minus b times 1 over root 1 plus root 1. That's 2. And so our answer is going to be C. All right, that finishes off question number 16. We are officially done half of our 2016 midterm, and I will see you for the next 4 questions in the next video.